G'day everyone. Just recording another guide to today's topic, which is about what we call Ionic Nomenclature. And so nomenclature simply means name calling, the system of naming chemical compounds. And a lot of important chemicals are ionic compounds. For example, sodium chloride, sodium hydroxide, calcium carbonate. I could go on and on and on. There's some basic rules when we're naming ionic compounds. Number one, the cation always comes first, the anion always comes second. And it's really important that you know the charges of the ions. For the time being, on page 94, table 4.3, gives you a list of the ions, but it's really worth trying to put those into memory, and so that without having to think too much about it, that you can remember the charge of a particular ion. Another key rule, that when we write a compound, the charge should be neutral. The number of positive charges should be balanced by the negatives. And there's a simple sort of technique called swap and drop, which usually works to help you give it. It might not always give you the simplest, but it almost always does. Finally, don't write charges in the final compound. When you drop down, you shouldn't see the charges in the final compound. It should be understood that there's still ionic. It'll probably be easier to understand this when I give a couple of examples. So I'll move on to the next slide if you'll let me. So for example, if we had to write the formula of potassium oxide, and so actually you'll notice that the anion, it looks like the name of an element, but it'll often have this "ide" or sometimes "ate" ending. "Ide" just means that it's the anion or the non-metal. You can recognize ox is the start of oxygen, and then "ide" shows that it's an anion. If you've got potassium oxide, you've got potassium is always one positive, and oxide is two negative. You can see that in table 4.3. Check it out. So what we do, the 1 plus here gets swapped onto the oxygen and dropped to the bottom. So we just have 1 here. The 2 here, we're not worried about the positive and negative. Gets swapped onto the potassium and dropped. We write it as a subscript. So what we end up with is K2O. And that also makes sense mathematically, that if you've got two K positives, you've got a total of two positive charges. And if you've got two negative, you've got two negative charges. And so the two positives balance out the two negatives, you've got neutral charge overall. Second type of problem you've got is you might be asked pretty much the reverse question. Name the compound MgF2. And this one's generally easier. Identify the ions involved. Mg2 plus is magnesium. F minus is fluoride. And so that means that this compound, MgF2, is magnesium fluoride. Next, here's a twist. And there was a couple of twists here. Some elements are going to have variable charge. This is especially the transition metals, the D block. And so, for example, just two examples, iron can either be Fe2 plus or Fe3 plus. Another element, copper, can either be copper 1 plus or copper 2 plus. And so what do we do in these cases? If you're given the name of the element, then of the compound, then it'll have to include the charge as Roman numerals. And so you'll see sometimes copper in brackets I bracket oxide, which means copper 1 oxide. And if it was copper 1 combining with oxygen, that would be Cu2O. Or you could see copper bracket II oxide, which means copper 2 plus oxide. And that would combine with oxygen to be CuO. So that's one possibility. Okay. Another possibility is if you're given the formula instead of the name, you can infer the charge from the anion. And so, for example, if ions combining with oxygen and you're told the formula is Fe2O3, since we know that oxide is 2 negative, and so that would be the swap, then it must be that the ion is 3 plus. Like that's bound to be the case. Like it has to be. That's 6 negative charges from 3 to negatives. So you need 6 positive charges from the ion. Twist number 2, what we'll call, or what are called, polyatomic ions. And so poly just meaning many, atomic meaning atoms. And so these are ions, usually anions, which have got more than one atom. For example, nitrate, which is NO3 negative. So NO3 with the negative, I'm just going to quickly swap into the textbook here. So you'll see this picture in your textbook. This is a carbon combining with 3 oxygens, and the overall charge of those 4 atoms is 2 negative. And so we write it as C, the 1 carbon, and O3 because I've got 3 oxygens, and with that 2 negative, which is the charge on the entire group of 4 atoms. Another good one to know is this one, where you've got nitrogen combining with 4 hydrogens, and those 4 atoms together have a positive charge. And this is one of the really rare cases where you've got a cation which doesn't involve a metal at all. This is called ammonium. And so NH4 positive is an important ion. So this is what these polyatomic ions look like. A couple of things which normally happen with the name. If the other element is oxygen, and pretty much it always is, the name will end in 8. And so I could have nitride. Nitride would be N, and if it's ide, it's just the element by itself, like nitrogen as an anion. So nitride is N3 minus. Nitrate, NO3, is 1 minus. Sulfate, SO4, has got a 2 negative charge. And it's not obvious from where the atoms are found on the periodic table what the charge is going to be. That's really something that you need to know. Nitrate, you need to know sulfate, and probably 2 more. Phosphate, and which is NPO4 3 minus, and carbonate, CO3 2 minus. If we're writing names, if there's more than one, you put a bracket around the entire ion, the whole ion. For example, calcium nitrate, 2 parts. Calcium is CO2 plus. We could find that in our table, or we might know that because calcium is in group 2, and nitrate is NO3 minus. this one here. So if we're doing our swapping, the 2 here is going to go onto the nitrate, and we put all of the nitrate in a bracket. And so just like in maths, this bracket means that I've got 2 of everything inside the bracket. And this is a 1 minus charge, and so this 1 swaps to the calcium, and because we don't write ones. Pretty much the last thing, when don't you swap and drop? We don't swap and drop when there's a simpler ratio. Here's a simple example. Magnesium sulfide. Magnesium's a metal. It's got a 2 plus. Sulfide is the anion. It's S2 minus. And if I was just like not thinking and just following swap and drop, I might write that as drop this 2 down to the S, drop this 2 down to the here, and write it Mg2S2. And this is, although mathematically it might make sense, it just looks wrong. That it's simpler to write Mg1S1 because one of these 2 minuses balances one of these 2 pluses. And that's it for today. Practice, practice, practice. This is like a key skill. You really want to learn these ions, write them down on flashcards, learn them, learn them, learn them. I've given you, 5 or 6 questions here, but more is more with this one. Hopefully see you on Thursday. Good luck.